next key feature is end behavior. Now, the only thing challenging about end behavior is the notation. So before we get to the notation, I want to be sure that we understand exactly what we are talking about when we say end behavior. We literally want to know what is going on at the end of the graph. So here's one end, and here's the other end. So we have a left end, and we have a right end. So when we talk in behavior, we are asking, as the graph goes left, the graph goes, and we're wanting up or down here, okay? And then for this side, as the graph goes right, the graph goes up or down. Now, I am using verbal descriptions, and as soon as we understand those verbal descriptions, then we're going to use the mathematical notation, all right? So for this particular graph, as the graph goes left, the graph is also going down, okay? And then as the graph goes to the right, the graph is going up, isn't it? All right, so that's easy enough, right? So you go to the left and decide, is the graph going up or down on the left side? Then you go to the right and decide, is the graph going up or down on the right side? So that's not hard. We don't like to have to write all that out in math though, right? We like shorthand, kind of like you do an LOL on text instead of writing out, I am laughing out loud. All right, so we're gonna do the same thing here with this. We are going to use symbols to make the statement, as the graph goes left, the graph goes down, okay? So for this portion right here, as the graph goes left, we are going to say as x arrow to negative infinity. All right, so let's look at this. This is as the graph goes left. Okay, negative infinity is left. Now, we've only said half of this statement though, right? We've only done as the graph goes left. So as the x's, that little arrow means goes. So as the x's go to negative infinity, y's, we're going to put a comma up there, y goes, and we said that it went down. Well, on the y-axis, down would be negative infinity. Now we're using infinities because there's an arrow, so it's going on forever, okay? So this right here is just the left side. Oops. Sorry about that. Okay, now I'm going to do the right side in green. So we're going to do this side in green. So we have another side, so we need to do this whole statement again. As x goes, but we're not going left, we're going to the right this time. So that is positive infinity, comma. The y's go, well, where are the y's going? We said that they were going up. Well, up on the y-axis is positive infinity. Now, in this particular situation, this and this are both negative infinity, and this are both positive infinity. That won't always be the case. We actually have to look at the graph to decide which direction it's going. Okay, now I'm going to clear this off so that we can see everything on here a little bit clearer, because you should have been taking notes. What I'm going to do is in a different color. Let's do orange. I'm going to give you these symbols as x approaches negative infinity. So for this side, this is the notation you use. And Up here is y approaches positive infinity. Down here is y approaches negative infinity. When we go to this side, we say as x approaches positive infinity. So look here, the arrow was in this quadrant, and that as x approaches negative infinity, y approaches negative infinity. That's what we've got right here. This arrow was in this quadrant. As x approaches positive infinity, y approaches positive infinity, which is what we've got right there. Both of those statements, this and this, is a single answer to the end behavior of this graph.